Onboard software has been produced by Thales Alenia Space in Spain for several years now. The high criticality of this type of software demands a strict and iterative validation process. An important phase is the testing in simulated environment that allows early detection and correction of anomalies. Then this phase is followed by the testing with representative hardware that is controlled by the onboard software. We noticed that the work performed during simulated and hardware phases was not as optimized as it could be, as different testing environments and teams were involved, and manual tasks were still performed, with the associated human errors, lack of traceability, longer hours, and typical limitations derived from manual work. Therefore, a self-funded research and development initiative was started in 2019 by Thales Alenia Space in Spain to implement the Unified Software Sequencer, USS, a test engine that can be used with any software validation facility for indistinct simulation testing and real-time hardware testing. The USS has been designed to embrace the whole test lifecycle with agile methodologies and offers an end-to-end solution that covers all the phases in software testing automatically. This includes from requirements identification and mapping, test design in natural language, test implementation using glue code and COTS technologies, test execution campaigns, and test reporting and project KPIs. The USS is currently operative in all the software validation facilities used in system testing of an instrument control unit onboard software. Now the USS high-level architecture will be explained by David Rodríguez.
The solution we present is based on Jira with the X-Ray plugin for requirements specification and test management. This plugin allows to define tests in Gherkin format, which uses natural language syntax and enables domain experts to interpret and translate complex requirements into readable sentences which can then be coded by software developers who may not necessarily be as well versed in the project domain. The module that takes care of converting these natural language sequences into lower-level commands is the so-called glue code, which basically consists of a Java framework known as Cucumber that helps in defining what needs to take place for each instruction. These instructions are then forwarded via REST API to a server, which can either be a simulated environment containerized with Docker or a complete hardware test bench where physical interfaces need to be previously set up. Once the tests are run, a report is generated and automatically made available back to the Jira server for result visualization and progress tracking. Finally, add that the presented schema can be scoped within a continuous integration engine which triggers the test runs and launches the validation processes each time a new release is created. After a brief introduction to the system architecture of the USS, Carla Salas will now point out the most relevant conclusions we extracted from the project.
Thales Alenia Space in Spain Unified Software Sequencer has proved to be beneficial to all actors involved in software testing: project management, test designers, test developers, and quality assurance. It has improved our efficiency. No special test implementation needs to be done regarding the simulated or the hardware environment. The glue code is implemented once, and the very same test is executed from our unified sequencer regardless the test environment. It promotes reusability. The USS can be easily adapted to different missions, and all actors have visibility of what is being tested thanks to the agile tech stack that automatically tracks progress of the test campaigns and displays updated reports and KPIs. A recommendation derived from the early stages of USS design is that it is very important to select the vocabulary and the syntax of the natural language in order to allow a smooth conversion into glue code and a good test prototyping. We are very happy with our unified software sequencer. and we are working on its integration with Thales Alenia Space in Spain Test Bench Controller to be able to face validation campaigns of onboard software that interact with all the typical communication links and bases in space.